So let me start with the announcement. Just a quick one. For those people that missed the online test 2, if you missed the online test 2, just make sure you send me an email because you still need to write that online test 2. So you send me an email, then we make an agreement on when you will come to write on campus for those people that missed the online test 2. So please make sure you send me an email, then you'll be notified in terms of we'll come up with an arrangement to check to see that you come and write that online test 2 that you missed. And let me quickly also say this, the online test 2 memorandum, we are not going to release until, because some students missed the online test 2. So the memorandum will only be released after those students that missed the online test 2 have written. So, and I think that will be around the study week like we did last year. So if you missed the online test 2, please send me an email, then we agree on a date that you come to and time that you come to campus and write. If not this week, at the latest next week, because by upper week, I believe everybody's supposed to have written. So that is for those people that miss the online test 2 owing to sickness or any reason. And make sure you come with your proof, maybe sick notes in terms of things that serve as a proof of why you missed the test. So that is for online test 2. And those people that maybe miss online tests, that means the first test, which is the test 1, owing to also sickness or any other reason, the date for that test will be communicated. It will be communicated before the end of this week or early next week. So, but we are targeting around a week before the recess. So those people that have missed the test 1 will be writing that test. So the scope of the test will be confirmed. For the scope of that sick test to be confirmed, I think by the end of this week or early next week via Moodle. So that is another announcement. And another thing which I also want to quickly echo, don't forget time is not really on our side. So, and don't forget, so far we have been pushing bit by bit, and we have to really push because the plan is to make sure that by the end of next week, we finalize the remaining modules that we have. So it's not a lot. We still have, like, we need to finalize deterministic dynamic programming, then go to probabilistic dynamic programming, which is not a lot of concepts. And the last issue, which is network models. So that is just one concept. So we need for us to finish by next week, because the plan is to make sure that by the end of next week, we are done. Then the other week, those people that missed the test 1 can write their sick test. And at least from by the end of next week, you also start having time to start preparing for the summative test. So by next week, I will tell you the scope of the summative test. And don't forget, I've also echoed it. Tentatively for now, the summative test is on the 4th of June, 2024. So the time and the venue after it has been, I think I've talked about the time, which is 5 to 8. The venue after it has been confirmed, I will let you know. So please take note of that. So that is also another quick announcement from my side. And just like what I was saying now, for us to be able to finish all our module next week, we need to have extra class this week, Friday. So please take note of that. There will be extra class from 5 to 7:30. So I believe with that 2 hours, 30-minute class, I believe by the time we'll come next week, Tuesday, we'll be able to finalize the last module. So then we know by the end of next week, Tuesday class, we are done with everything. Then we have more time to start preparing. So please, I'm just echoing it again. Please take note. There'll be extra class on Friday. And the time will be from 5 p.m. to 7:30 p.m. So that even if you want to do other things, you can do after 7:30. So please bear with me because I don't want to rush the module, but I want us to take it slowly. You understand it. Then we still do extra class to make sure that at the end of the semester, all the concepts are clear and you can do well in your summative test. So are we all sharp? Please just indicate with the extra class on Friday, just confirm Thank you, Sayanka. I'm waiting for everybody to respond. Good. Thank you. Please don't miss the class sessions. You need to be there because they are very important. And don't forget, we are now going to the test, the summative test, which is weighing high marks, 45%. So you cannot afford not to be in those extra classes and the remaining classes. Please make sure you avail yourself just for that extra class. I won't disturb you after Friday for extra class. So, so I think that's another information. Then what I've also did to help you, I think our assignment, when is it due? Is on the 11th, right? Please, if you can confirm via the chat. On the 11th, yeah. So what I've done to help you because of me trying to create extra class so that we can push, I've decided to shift the date to next week, Wednesday. So I'm going to update the final date of the submission of the assignment to next week, Wednesday, so that at least me, I'm the one bringing you to class. At least it will give you time to finalize the assignment. But because we need to have that extra class so that we can push, time is not on our side. So thank you, Ndikinda, for that. At least it will give us also more time to finalize it to our satisfaction. And don't forget that assignment weighs a lot of marks. So I'm just also giving that time so that at least you can push and apply your mind to it and make sure that anything you are producing at the end of the day can give you a very good mark. So that is also another announcement. So by tomorrow, you will see that updated assignment deadline date on Moodle before the end of tomorrow. So that is also another thing which I've done to at least help us during this busy period for all of us. So then what again do I want to say? I know that I've been receiving some emails from some students in terms of saying maybe test two you didn't do well. Please, even if you have not done well in the first two tests, it's not the end of the road. Like I've explained to all those people that send me an email, don't really lose hope because what you have covered so far is just 25% of the total mark. So put more effort for now on the assignment. Hence, I'm even giving you more time to do it properly. Put more time on the assignment, that weighs 30%. If you can do very well in that one and prepare now from now and start preparing, revising what you have done so far in preparation for the summative test and also preparing for what we are going to cover for the remaining modules in the semester, then you'll be very good if you can do very well in the summative test and the assignment. So there won't be a need for you to even have need a makeup test. You can even still get distinction because we still have 75% to go. So please put more effort on these remaining two assessments. That's my advice for now. But if maybe at the end of the day you are not crossing the Red Sea, then and you have also been attending because we check the attendance rate, then for those students we try to give a makeup test, but that would only happen for those students maybe towards the end of the semester after we have finished the summative and all those. So student that score less than 50% will be given like the last opportunity to write a makeup test. And that mark will be just to mark up their final mark to 50%. It won't go beyond that. Just to make sure they are able to cross, if they are able to cross with the makeup test. So that is the arrangement, and that's how we have been doing it for years. So please take note of that. I think with that being said, let's move on. So please don't forget this Friday class, 5 p.m. to 7:30, we are meeting again as agreed. So I think with that being said, let's quickly hear from you, from the class. How was the test? How was it? Maybe anybody that wants to just talk, just to reflect on the test. I think I'm sharing the wrong document. Sorry for that. And to share the document. How was the test? I'm going there now, just a moment. Reasonable, thank you, Ndikinda. It's reasonable. It's not that bad. And if you look at the way the questions are structured, if you have really practiced, there's nothing new. The computation procedure is the same. The scenario structure is the same like what you see in the examples. So if you have really practiced, I don't know. So I still believe maybe people that are really sweating with that test are the people that you didn't practice enough. Maybe you are doing it 9 minutes. So hence, I've told you and I've been shouting it several times. This is a mathematically inclined model. When you are taught a concept, make sure you practice those tutorial questions and the examples. Hence, I gave you those questions to master. So that now when you are preparing for the final test, you are just revising what you have practiced. Then you have that confidence. So I'm just advising, but like I've said, even if you have not really did well in the first two assessments, it's still not the end of the road. We still have 75% to go. So that means if you can push for that and fight hard for that, distinction is still even possible, depending on how far you can fight and push. So I think with that being said, let's move on. So today we are going to move on and look at, don't forget we've started looking at, the various type of inventory models that you can use to manage inventory. And we have seen the economic order quantity model to manage a deterministic inventory problem, where the annual demand for those inventory items are known with certainty. We're able to calculate the EOQ, calculate the reorder point when the lead time is 0 and when the lead time is not 0. So we look at that. How about if you have different kind of order inventory problems, how do you deal with it? And that results into other types of inventory models. But before we go to other types of inventory model, let's look at another example here that you can use EOQ to deploy, especially if you find yourself maybe working in the transport department. You can see how the concept of EOQ could be deployed there in terms of scheduling buses to various stations to convey people from one destination to the other. And you can use this approach to know how many buses should be scheduled per hour. So if you are the transport manager or the operations manager for a particular transport department. So how do you deploy EOQ in that context? We'll look at it with this example, and you see how we are applying that in this context. And for some of you who are working in the transport department, you can see that you can deploy this to come up with optimal bus scheduling solution for the organization, so that be able to also minimize the queue time that people are spending at the stations. So let's see, if you look at this example, they said, just to show you how this concept work, how EOQ is being applied in terms of bus service scheduling. They said each hour, the student wants to ride a bus from the student union to fraternity row. So you can look at this problem from the context of, even if you look at the UJ Transport Department, how are they scheduling the buses to each of the terminals where students are waiting? So if you look at it from that perspective, so you can see that this concept is very, very important. So if you are the operations manager at that transport department, you can apply what I'm saying now, or you are working the transport department. So you can see how this concept work. And I'm saying all this so that most of you are working in various organizations. Maybe what I'm saying can be applicable to you, which you can apply. So let's see. Each hour, these students want to ride a bus from the student union to fraternity row. So you can think about it like students arriving at UJ DFC bus terminal and they need to go to APK bus APK. So if you look at it like that, and we have so number of students. So these students is the number of students that are arriving per hour. So you can look at it in terms of annual demand that we have been looking at in terms of how many inventory that is required annually. But now in this case, we are looking at how many students are arriving per hour. So D now is like the hourly demand for buses in terms of number of students that are arriving to be carried by a bus to the next destination. So that is the hourly demand, which you represent as D. So you can look at it from the concept of EOQ as the annual demand. So I think I've explained that. And they say the administration places a value of $8 on each hour that a student is forced to wait for a bus. So you can see where this is more of you solving a queuing problem, because at the end of the day, the question you are asking yourself as the operations manager of that transport department is, how should we schedule buses to the bus terminal on hourly basis to minimize the queue time spent by the customers. So if you are trying to solve this, like you are seeing here, you can deploy this context, and you see they are saying the admission places a value of 8 hours on each hour that a student is forced to wait. So this is more like the cost I shared with allowing student to wait. So the way we calculate that in practice most of the time is a function of you calculating the cost of lost opportunity. Maybe student waiting there for 1 hour, they would have done something which would have generated a particular value in terms of money or something. So if you want to calculate the cost of waiting time, you can look at the literature. They tell you how to calculate the cost of waiting time associated with allowing customers to wait. And you can use that to estimate the cost of waiting. But in the test, if you are given scenario like this, you'll be given those parameters. But if you want to apply it in practice, you have to do what I'm saying. So, like I was saying, yeah, they said that the administration places a value of $8 on each hour that the student is forced to wait. So that means in this case, this is more like the holding cost. If you look at it, because you look at it like inventory holding, that means in this case, it's the student that are holding, waiting. And the cost I shared with allowing them to wait is H. So I hope that makes sense to you. And they said it cost the university K dollars to send a bus from the student union to fraternity row. So how much from the bus department to how much do they spend in terms of fueling the bus, as well as maybe even fueling the bus, as well as even the money of paying that particular driver within that period to ship. Because if you know the hourly wage, you can now look at it in terms of how long does the does the driver spend to move from the bus department to the terminal station. Then you can work out the corresponding amount of money that he has collected within that period in line with the amount of which is collecting power. I'm just saying if you want to get that K in practice. But in the test, you have to, those parameters will be given. So they said it cost the university K dollars to send the bus from the student union to fraternity row. It cost the university K dollars to send the bus from the student union to fraternity row, assuming that the demand occurs at a constant rate. So if you look at it before I go to the next statement, the cost of you sending bus to the station where the students are waiting, that is your ordering cost. If you look at it from the concept of EOQ, in terms of cost of you placing the order. So in this case, it's more like the cost of you sending the bus to the bus terminal to pick people, to pick the students waiting. So that is your K. And they said, assume that demand occurs at a constant rate. How many buses should be sent each hour from the student union to the fraternity row? So look at it here, assuming that the demand occurs at a constant rate. You remember we assumed that the demand is always constant. It's one of the assumptions of EOQ. So you see, this is also obeying the law of EOQ. We assume that the number of students that will arrive on hourly basis is always constant. If they are constant, then the question is how many buses should be sent each hour from the student union to fraternity row. If the demand is constant, but if the demand is not constant, that means you cannot use EOQ. You have to use more of a dynamic programming approach because the demand changes over time per period. To be able to know how many buses should you make available in hourly basis to minimize the total cost of waiting, plus minimizing the total cost of waiting for the student, as well as the total cost of total cost of making the bus available, depending on how many buses you want to make available. So I hope I'm making sense. That's why I'm saying it several ways so that you understand the context. So if you look at this question, the question is saying how many buses should be sent each hour from the student union to the fraternity row. So if you look at this question that they're asking you, is more of like number of orders to be placed per year. So which is like your N. So that means in this context of this problem, the EOQ is a function of when the bus arrives to the bus terminal, what must be the maximum number of student that he must carry, that the bus must carry. That will be your EOQ in this context. So depending on how many they carry for each bus, the question is now is how many buses should we make available? And that's the number of orders. So if you want to determine how many buses, you are looking for the number of orders, which from the concept of EOQ, and if you can look at it before I even solve it, but I'm just trying to explain to you. So the number of orders is how many number of buses, but if you look at the behavior of this problem, you can see, you can look at Q as a function of the number of students that arrive over time. So if you can look at the graph, maybe when we start at a particular time T, students start arriving and they start increasing over time. Then when they reach a particular Q, which is the maximum EOQ in terms of number of students that the bus can take based on our calculation of the EOQ, then all those students that has been waiting over a particular time period would all be now taken by that particular bus. And if they are taken, that means your Q now will shoot back to zero. That's why you see the line shooting back to zero, meaning that the first bus has carried this one. And that is the fourth ordering phase if you look at it from EOQ. Then from there, the queue starts again. A student arrive. When it reaches queue, they are carried by another bus based on your EOQ. Because you are saying that when the bus arrives, if the EOQ has not been reached in terms of the number of students that we have calculated that they must carry, then the bus must not go. And that is also what you are seeing. You remember, when you check what is happening at the bus terminal, there's a waiting time. Or maybe they use two methods actually. Sometimes they use waiting time, especially during the busy period, and to say, okay, when maybe within the next 15 minutes, depending on how many students that the bus can carry, it must go. Or in some cases, some operations manager use the number of workers that, the number of students that have entered the bus to now know when should the bus leave. But the question is, which of them is the best? To be able to make sure that we minimize the waiting time experienced by the students or the customers that need to go into the bus, as well as minimize the cost of scheduling the buses, so that we minimize the number of buses that we are scheduling. So that in that case, we minimize the number of drivers that we need to hire and minimize the cost of buying fuel. So if you look at that kind of problem, that's what we are looking at here. So in that case, you can see it's a very interesting subject matter. So that means in this case, you see what we are trying to minimize, but I'm not going to go through the formulation, but just to show you, we are not going to go into the formulations, but just to show you how this talks to the EOQ. So what we are trying to do here is we want to minimize the total cost of making the bus available, which is a function of the cost of sending the buses, depending on how many buses we are sending, and the cost associated with allowing students to wait, depending on how many students are waiting in terms of the total cost. So the question is, how many students should be carried by each bus in such a way that will minimize this total cost, and that will be your EOQ. And that is, you see, we started deriving the ordering costs formula, which is a function of D. D is talking to how many students arrive per hour. Q is talking to the EOQ, the Q that we want to go and determine to minimize the total cost. Then multiply by the cost of sending the bus. If K dollar is the cost of just sending one bus when you send it. So depending on how many buses you send, which is how many buses you be sent per hour, which is D over Q, which is more like your number of orders, then in that case, your total ordering cost will be KD over Q. But nobody will ask you to prove this, but I'm just showing you how it relates to the EOQ. So then the student waiting cost is also more like your, if you look at the area of the graph, like I told you, you find the area of this triangle, which is the area of the number of customer waiting over time, and you know how we derive that. That will give you QH over 2, and H in this case is associated with cost of waiting. Following the same principle like how we derive the EOQ, you can see the total cost will give you HQ over 2 plus KD over Q. Then you can go and find the TC DQ. And if you do that, you see the final formula you get, it's synonymous to your EOQ square root of 2KD over H. That's why we said for a bus scheduling problem, you can use EOQ formula to solve it. Does that make sense up to the stage? Just use a reaction, or if you have questions, you can ask before we now see an example in line with this. Thank you, Sianka. I'm waiting for other people to respond. Perfect, Sakiwe. Please respond, do respond. Thank you. Thank you, Ndikinda. So I hope that makes sense. Good. Perfect. Thank you. Good. So, and one thing that you notice about these modules, you can see these are interesting subject matter operational issues. So we are dealing with different kind of operational issues, and most of you might be even working in that area. So maybe you can apply some of these concepts to optimize your operations. And in that case, who knows, maybe you can get promotion at work if you come up with something that is better than what they are currently doing. So let's see with this. The EOQ, which is the number of students that must go into each bus, is square root of 2kd over h. So, and if you know the EOQ, if you want to know the number of orders, which is talking about how many buses should we make available per hour, that will just give you your capital D over EOQ after you have calculated the EOQ. So let's see the example that we have here. They said, and don't forget, if you want to know, another thing which you can also be asked in line with this question, aside from the number of buses per hour, they can ask you, what is the time between buses? What is the time of leaving between buses? So which is more like the reorder point. So in that case, you look at, if they ask you to say, when we talk about time between buses leaving, it means that when bus 1 leaves, when next should bus 2 leaves, when next should bus 3 leaves, depending on how many buses you're supposed to leave per hour, which is your number of orders. So that is the reorder point in this context. And the reorder point is EOQ over D. So if you have calculated your EOQ, which is the number of students that each bus must take at the bus station, and you know the D, which is the number of students arriving per hour, if it's per hour or per day, depending on the period you are looking at as your D, then in that case, you can find the time between the buses leaving, which is your reorder point, which is EOQ by D. So let's just look at this example. They said, for example, if H, which is the cost of allowing student to wait, because in a test, you can be given this scenario, instead of mentioning D, they can say each hour, so number of students want to write what, and you are giving each value and you are giving a K value in line with this, and you ask questions in terms of, you can now be asked questions in terms of how many students should be carried by each bus when they arrive at the bus terminal. That means, like I told you, they are looking for EOQ there, which is square root of 2dk over h. The next question which you can have is how many buses should be available per hour? Because in this case, we are dealing with hourly as the period. That is the number of orders. And the next question which you can be asked, which we are going to now do for all the questions I'm saying now, what is the time between the buses leaving? What is the time between the buses leaving at the at the bus terminal station, and that is the reorder point. So if you ask those 3 questions and you're giving those parameters, like we said, for example, if H in line with that scenario is $5 per student per hour, which is the cost of allowing student to wait, and they said the D in terms of number of students arriving per hour in line with that scenario is 100 students per hour, and K is $10 per hour, which is the cost of sending each bus from the transport department to the bus terminal. Is $10 per bus. Then the first question which you can be asked is, like I said, how many students? Because the question they ask here is how many buses, and that is the number of orders, and you cannot determine that without first answering this question, which could be the first question you can have in the test, is how many students should each bus carry from the bus terminal? That means you are looking for EOQ, and that is square root of 2kd over h. If you do that, in this case, we have seen that our K is $10. So that will give you 2 times K, which is 10, times D, which is 100, over H is 5. Then if you find the square root of this, which is raised by half, then EOQ is 20. And this result is telling you that the number of buses that need to be carried by each bus when they arrive at the bus terminal should be what? 20 students. And that is the answer to this problem. Then the second question, which is talking to the question actually asked there in the slide, to say how many buses should be sent each hour, which is talking to the number of orders. And that one I told you is just D over EOQ. That is number of orders. And our annual demand is 100 from the question over EOQ, which you have calculated is 20. So that means the number of buses that need to be sent per hour is 5 buses. If you get a fractional solution, you just round it up because you're going to have a fractional bus to the nearest whole number. So that is the next question which you could be asked, and it has been answered, which is talking to the question asked in the slide. Then the next question which can be asked also is, what is the time between buses leaving the transport department? So if you ask that, that means you are being asked the other point, and I told you the formula is EOQ over D, and that means in that case is EOQ, which is 20 over D, which is 100. So 20 over 100 will give you 1 over 5. So, and that the answer you get will be in hour, because you remember the period in terms of, they said each hour. So that means the answer you get for the other point will be in hour. If it's day, if they say each day, then means your answer will be in day. If it's month, the answer will be month. But in this case, it's each hour. So that means the answer you get is 1 over 5, which is 0.2 hour. So you can convert it to minutes, which will give you 12 minutes. And this result is saying when the first bus leaves at the first minute, which is minute 1, in terms of you developing a bus schedule, in terms of how they must leave the transport department, the second bus must leave after 12 minutes. So maybe the first bus leaves at 1 minute, the next one is leaving at 13 minutes, the next one is leaving after 12 minutes, like that. Then you come up with a bus schedule. Then you give to the bus drivers, then they know when to leave. So, and those are the questions. So you can see how powerful this UQ could be in terms of helping transport department to come up with an optimal bus scheduling solution to minimize the queue time experienced by their customers. So does that make sense? Does it make sense before we move on? So don't forget, in the test, the scenario can also come like this. Thank you very much. Good. It means we are all fine. Scenario like this, like that scenario will come. I will just change the parameters, and I can ask you all these questions that I've said in line with it. So there's no question on bus. Let me see if there's a question on bus scheduling there in the book. But I know we don't use to, there's no one specifically, but if question on bus scheduling will come, it will be the same scenario. I might just change the parameters and now tailor make the scenario to talk to South Africa. That's the only thing I could do. But let me see quickly if I see. I'll be with you. So I'm almost there. I'll be with you now. I think all the questions that talks to, there's no question on that one. I think most of the questions that how UKIS has been applied in a banking situation, we have looked at that together. So I think there's no one specifically. So if the question will come on this concept, like I told you, it will be the same scenario, the parameters just be changed and customized to a South African scenario. So that is how EOQ can be applied in terms of bus service scheduling. And don't forget, with the other exercises you have already seen also, how EOQ can be applied in terms of knowing how many times you must go to bank to withdraw money. We saw those kind of questions. So you can also deploy EOQ concept to maybe to advise customer in terms of the best withdrawing policies that minimize the number of times that they go to bank and minimize their waiting time the number of times they visit the bank, and all those. So if you're a operations manager there, you can deploy those kind of concepts. And we have also seen how that can also be applied at a retail shop, like a pizza shop. So we saw that. So if you are working in the retail shop, I'm just echoing these things because some of you just cram these things, but you don't really look at it in terms of application. So that if you are employed in those kind of environment, you know I can go and apply what have been taught in class in this area to improve operations. So we saw with question number 3 in page 858, how you can use EOQ also to know how often should you send out maybe trucks or bikes to deliver maybe to deliver food product required by customers staying at various locations. So those are holistic various areas of applications of EOQ, aside from inventory, aside from managing inventory. So I think with that being said, we have looked at various areas, but let's now look at more inventory models, which can also make you understand the characteristics of inventory problems better. And when do you now, based on the nature of the inventory problem that our organization is faced with, then when do you know that I'm not supposed to use EOQ, now I need to switch to this other inventory models? We've seen the assumption of the EOQ, and we agreed that when all those assumptions are obeyed, EOQ must be used. But how about maybe there are other assumptions associated with inventory managing an organization? Which inventory should you use? So there are other inventory models like what we call the quantity discount model. You can write it down, or let me just put it on the chart, and I will tell you when you use that kind of inventory model now. So we've also got what we call the quantity discount model. How many people have heard about that before? And have you used it before in your organization? For those people that may be working in an inventory environment? Who has an idea? Have you heard about quantity discount inventory model before? Just type on the chat if you have not heard about it before. Maybe it's the first time of hearing something like this. Or anybody that has heard about it, you can just unmute and talk. What do you know about it? Let me check with Indikinda. Have you heard about it before, Indikinda?
No, it's my first time hearing about it.
Okay, no, it's fine. Let's look at it together then. So with the quantity discount inventory model, this model is always used, and you will see why we call it quantity discount now. Because don't forget, some suppliers, they tend to give, and we have also seen that even with the retail shops, they tend to tell you that because they want to entice you to always buy from them, because don't forget, they know they are competing with other supply organizations. So they tend to say, okay, if you are able to buy for inventory, for a particular inventory item, if you buy a specific number, maybe the normal price of that item per one, maybe is 20 rand, I'm just saying. Then they might say to say, if you buy a dozen, which is 12, then you are going to buy, if you are able to buy a dozen, you buy it at a price of, instead of buying it at 20 rand, we are giving you at a price of 18 rand. So that means in that case, that's why we call it quantity discount. And you can even do it in various batches. So if you buy 1 dozen, we are selling it at this price of $18 per one. If you buy 3 dozens, we are selling at the price of maybe $15 per one. If you buy 5 dozens, we are selling at the price of $14 per one. Then don't forget, as a customer, you'll be enticed to say, hey, this thing is cheap. But the question is it really worth it to buy a lot of inventory item, even though it's coming at a cheaper cost, in such a way that we are not minimizing the total cost of managing inventory? Because when you buy more inventory items, then you need to stock it. Do you have enough stock capacity? You know that stocking inventory, we've talked about the various costs incurred. So is it really worth it to go and buy more stock? So that is what this quantity discount model tends to advise you. So anytime you have a situation where the supplier is giving you discount for the items you can buy, then you ignore the EOQ, you explore the quantity discount model. But the way it works is it will still, quantity discount model still use the EOQ formula, but now you want to explore you maybe buying at a particular discount. Is it really economically viable to do that? And what is the EOQ that help you to, what is the EOQ? Dlamini, your video is on, maybe you can off it. Your camera is on, you can off it. Dlamini? Okay. So like I was saying, so you are going to be asking yourself, what is the EOQ? What is the best EOQ that you must buy to take advantage of the discounts that they are offering you and also minimize the total cost of holding those huge inventory items? Because when you buy more stock, you are holding more inventory. So how do we do that? Anytime you have that kind of problem, you must use a quantity discounting model. So you know that anytime your supplier is willing to give you discounts, then go for quantity discount model. So how it works is you still use the EOQ formula, and I will show you with an example. So let's just look at this example in slide 13, then you see what I mean by that. Then you see we still use the EOQ formula, but we want to go and determine the EOQ that harness the opportunity of getting discount and minimize the total inventory holding cost. So let's look at this example and see how we do that. And I will show you the step from there. They said a local accounting firm in small town orders boxes of floppy disk. So a local accounting firm in small town orders boxes of floppy disk. And they said each box has 10 disks in a box. Each box is having 10 disks. Take note of that. So it's ordering that from a store in megalopolis. So it's that, don't forget, this is more like a town. You can look at it like Johannesburg or something, because this book is written from America. So they are mentioning city over the city that side. So I think in the nearest future, we need to localize our textbooks so that we can be mentioning something and all those areas that we are familiar with, Tembisa and all those, Jamestown. So, but if you look at the megalopolis, it's more like you are talking about a particular area, a particular city or town. So they now say the price per box, the per box price or price per box charged by the store depends on the number of boxes purchased. You can see already this is a quantity discount model, because they are telling you if you purchase within a particular range, we are selling the price per box of the floppy disk for you at this price. So look at this information given us in the table. They said if Q is between, we have 0 less than or equal to Q less than or equal to 100, meaning that if your Q is more than 0 and less than 100, if you buy anything within that range, you are going to buy it at a price of $50 per box. If the number of boxes of floppy disks you are buying is between 100 and 300, less than 100 and less than or equal to 300, you are buying it at a price of $49. And if you buy more than 300, QB more than 300, you buy at $48.5. So the question which they are asking you now, but before we go into that, let's continue reading. So you can already see this is a discount, this is a quantity discount problem. So the question is, what must be the EOQ must buy so that we take advantage of this cheaper price if you buy at a discount and minimize the total inventory cost? How do we solve that? That's what we need to see. But they told us before we go now solving, they said the accounting firm uses 10,000 disk per year. That is the annual demand for disk. So that capital D is, remember I told you, you must always convert the demand to annual. We know that. So that means in this case, your D equal to 10,000. So take note of that parameter. And they told you that the cost of placing an order is assumed to be $100. And that is K, you remember, from EOQ. So your K, which is the cost of placing an order, is 100. So K equal to 100. And they said the only holding cost, which is now telling you what is happening in terms of holding cost, is the opportunity cost, which is assumed to be 20% per year. So it will be 20% per year, meaning that is 20% of the price of the inventory item. So please, if you look at the holding cost here, your holding cost is more of H, which is equal to IC. I'm going to type it on the chart. So H is more of equal to IC, meaning that that I is talking to the opportunity cost, because they are saying the holding cost here is a function of the opportunity cost of the capital, which is the cost of buying each inventory item, depending on how many inventory items you are buying at that discount. So I is talking to the opportunity cost, then C is the price of the item, depending on how many units you want to buy at each price given, depending on how many you are buying based on that table. So that means H, you must see it as IC. So I think you must understand that now. So based on this now, then it's easy for you now. The question they are now asking you is, each time an order is placed for disk, how many boxes of disk should be ordered? So that is your EOQ. How many boxes should we order when we place an order? That is the EOQ. So we need to calculate that factor, take into consideration this discount and minimizing the total inventory holding cost. We are not going to do the proving, but we are going to use our formula, EOQ formula, and try to solve it and see how we can harness this discount. So how many boxes of this should be ordered? We are looking for EOQ there. How many orders will be placed annually? That is the number of orders, you know that by now. Then what is the total annual cost of meeting the accounting firm's disk demand? So that is the total cost, which is a function of your, like I told you, your annual ordering cost plus your annual ordering cost plus the purchasing cost, annual purchasing cost. So we need to go and calculate those three. So let's go and take it one by one. How do we determine the EOQ? The way this works, if you are doing a quantity discount, as the name implies, we want to take advantage of the discount. So you go to the table given, you check which of them, because you want to take advantage of the one with the cheaper price. Which of them is the cheapest? Is the case where the price is 48.5? That means for you to harness this $48.5 to buy one box for 48.5, you must buy at least 300. Now we need to go and check. For us to be able to see whether is it really economically viable, or is it admissible to buy at this price in such a way that we are harnessing this discount and we are not holding a lot of inventory in our organization. So how do we know whether is it admissible to buy or economically viable to buy? You go and calculate the EOQ at this price. Calculate the EOQ at this price of this cheapest price and see whether your EOQ is it within this range. If yes, then it means that the EOQ you are calculating is admissible at that price. Admissible meaning that it's economically viable to do that. At least it will minimize your total cost. Let me write it on the chart. When I say admissible, I'm typing it on the chart. So that is admissible, meaning that is really the queue that you're buying would definitely help you manage your operating your inventory holding cost in such a way that you're harnessing the discount, and you are also at least having a reasonable holding cost for buying more. That's what we mean by admissible. So if you want to calculate that EOQ now, we use our EOQ formula again, because I told you EOQ will still work. So we start with EOQ of 3. So this one I'll call it EOQ of 3 because we are starting with price 3. We are starting with the third row because that's the one with the cheapest row. So hence we are saying here EOQ of 3 Then you find your square root of 2KD over H. I told you H is IC. So which is the opportunity cost given, which is 20% multiplied by the price, the cheapest price that you're considering now, which is 48.5. Take note of that. So if you do your EOQ there, that will give you square root of 2K. K in this question, we have seen it to be $100. Then D is 10,000. So you plug that in. K is 10,000. So you plug that in, which is, no, it's not, it's supposed to be 1,000. Sorry, because they're saying, they said, let's look at it. They said the accounting firm uses 10,000 discs per year, which is fine. But don't forget, you remember we said they are ordering boxes. So they said in each box we have 10 discs. So that means the number of boxes being ordered, it will be 10,000 over what? 10, which will give you 1,000. So some students will use this 10,000 directly. Don't forget, they are ordering in boxes, not in terms of disc. So if they are saying they are using 10,000 discs, so that means the total annual demand will be 10,000 over 10. To know how many boxes must be added to have that 10,000. Take note of that. And it's the reason why the D, when the parameter was noted, was 1,000 boxes per year. Take note of that. So that means your D is 1,000, so you can put it there. K is 100. Then over H, which is IC, I told you. The opportunity cost in the question to get your holding cost is 20%, which is 0.2, times the price that we are considering now, which is the cheapest prices of the item is 48.5. Hence, that's why you see us writing 20%, which is 0.2 times 48.5, then raised to power 5. Then you find the EOQ of 3. Press calculator. If you do that, that will give you 143.59. And that is the EOQ if you want to purchase at that price. So you check this value of EOQ that you have calculated. The EOQ that we have calculated at this price of 48.5, is it within the range of the Q provided that you can buy at 48.5 in the table? Don't forget, for you to buy at 48.5, the Q must be greater than or equal to 300. But the EOQ you are calculating at that price is not up to 300. That means EOQ for 3 is not admissible. And that's why you see, they say since EOQ for 3 is less than 300, because it's 1 for 3.9, that means EOQ for 3 is not admissible. And that means the only option you can consider, if you are very troublesome, is just to at least go and buy the minimum here. Because you can always say, I'm really adamant. Then in that case, if that EOQ is not admissible, just buy the minimum value in that range. But the question is it really economically viable to do that? We'll see. So that means what you can already conclude from here is that EOQ is not admissible, but you can consider buying a minimum of 300. That's why we say Q3 star equal to 300. So you can consider that option as your EOQ. But is that really the best EOQ? We'll see. Because you are trying to buy the minimum because that EOQ is not admissible. And the reason why it's not admissible is because the result we got for our EOQ for 3 is less than the range at which we buy at that price. I've explained that. So when you are done with that, the cheapest price, you go to the next cheapest and go and check whether that EOQ at that price is also admissible. If it's not admissible, you go to the last one. You go to the next price until you get to a case where it's admissible. That's where you stop. So let's go to the second one. The next cheaper price is 49.0. You calculate EOQ again. That means in that case, your price in this case at the second row is 49.00. So you calculate, and don't forget, we need a range. We need a value of our EOQ to be between 100 and 300 for it to be admissible. So we calculate EOQ for 2 at this price of 49, as seen in the table, because that's the next cheaper price. We do again 2 times square root of 2 times K, which is 100, times D, which is 1,000 over. How did they get this 9.8? This 9.8 is your IC, like I told you, which is 0.2. 0.2 times the price that we are considering now is 49, because we are buying at 49, which is the next cheapest price. So 0.2 times 49, if you press calculator, it will give you 9.8. That's how they got that 9.8, because I told you H is IC. And I in this case is 0.2, which is 20% of the opportunity cost. multiply by the price, which is the next price we are considering, which is 49. If you multiply 0.2 times 49, that gives you 9.8. If you press calculator, EOQ for 2 will give you 142.8. So if you check 142.86, if you check now the result you are getting for EOQ is within this range, which is between 100 and 300, because 142 is between that. So since you are getting a result which is between the range, already you can conclude that the EOQ for 2 is now admissible. But if EOQ for 2 is not admissible, please take note, it means that you must also consider another option of Q2 star being you buying the minimum, which is Q2 star being 200. That could also be another option. Then you go to the next cheapest price, which is you go to row 1 now and go and do your EOQ when you buy at this price. And you only stop the computation when it's admissible. But already, we don't need to go to the row 1 to the next cheapest price, because already at EOQ for 2 now, we're getting a result which is admissible. It means that our analysis of you getting EOQ that is admissible, it stops at that price. So take note of that. So that means the best Q that we need to consume is Q2 star being 142.86 boxes. So if you like, because we don't have fractional boxes, you can round it up to 143. But in the textbook, they didn't round up because we cannot have a fractional box, but we can look at it to say, the reason why I think they might not round up is because, don't forget, in each box, there are specific number of discs. So they might be looking at it in terms of saying, maybe you not buy a full box. So maybe for that 0.86 is talking to number of, maybe instead of you buying 10, maybe you buying maybe 7 or 8 to cater for the 0.86. Hence, that's why they are not rounding up. But if it's something that cannot be fractional, you have to round up to the whole number. So I'm just trying to tell you why they are leaving Q2 stars 142.86 and they are not rounding up, because each box has some number of what disk in it. So take note of that. So that means our best decision here, since EOQ for 2 is admissible, when we get to a stage where our EOQ is admissible, we stop there. And now we now analyze what is the best EOQ. And we have seen so far that when we get to EOQ that is admissible, that means that could be one of the EOQ that is possible, or it could be this Q3 star. We said we can also consider the element of buying the minimum. The question now is, should we go and buy the minimum at the cheapest price, or buy at this situation where EOQ is admissible? So there could also be 3 options. Let's say you are also considering Q2 star to be, let's say EOQ for 2 was not admissible, then you also have Q2 star being equal to 100. Buying the minimum in this range, then you go to EOQ for 1 and compute. Maybe that is at the stage where it will be admissible. That means you have 3 options to analyze and go and check which of those EOQs are giving you the minimum total cost. And that will tell you the best EOQ. So in this case, we only have 2. But I'm trying to tell you all the possibilities in the question. So in this case, Q2 star will be 142.86 or Q3 star is 300. But which of these options is giving us the minimum total cost? Because that is our goal, if you remember, even when we formulated our EOQ, so that we know the best EOQ that minimizes the total cost. And that will decide what we must buy. So that means for us to know that, we need to go and find the total cost of buying at 300 rand, of buying 300 units at a cheapest price of that 48.5. Then we need to go and calculate the total cost of buying 142.86 at the price per box of $49. Then you now compare the cost and see which of them is giving you the minimum cost, and that, based on that, that will guide you which Q you must go for, and that will be the EOQ. And that's how we do the computation. And that's what you are seeing here to say they started calculating the total cost for buying 300 units. Remember, total cost according to our formula when we're deriving the EOQ. Hence, that's why we derived it, so that you can see it here. It's a function of your annual ordering cost plus annual ordering cost plus annual purchasing cost. And we know annual ordering cost is KD over Q, if you still remember. So you can take that and say your K is 100. If you use that formula based on our derivation, K is 100, then D, annual demand is 1,000 over Q. In this case, the Q we are analyzing now because we are calculating the total cost at Q3 being 300. So that means that will be your EOQ will now be 300. Because we analyze the cost at that 300. And based on that, you see your annual drink cost to give you 333.33. So that's how you get 333.33. You do the annual purchasing cost also, and that will be DC. You remember the formula? So which is annual demand, which is 1,000 times C. And don't forget, this price is the price at which you are buying at 300, which is buying at the cheapest price, because that's when we got the Q3 star being the minimum at that range. So you are using that price at the cheapest there, which is 48.5. So if you simplify this, the annual purchasing cost will give you 48,500. Then the annual holding cost, you remember, is QH over 2, which is half times Q times H. That will give you half times Q, which is Q at 300 times H. I told you H is IC. And in this case, I is 0.2 times the price at which you are buying at 300 is 48.5. So if you multiply 0.2 times 48.5, that gives you 9.7. That's how they got this 9.7. It's 0.2 from the IC, because we said H is IC. So that means in that case, that will give you 0.2 times C, which is the price of the item, which is price at the cheapest is 48.5. So that will give you 0.2 times 48.5, and that gives you 9.7 there. Then the annual drink cost will give you 1,455. Then now you can add all these together to get your total cost if you buy at 300. Buy 300. So you see the total cost is 50,288.33. So that will be the total cost if you go ahead and buy 300 units. Then let's go and check if you buy 142.86 units, what is our total cost? And out of those two options that are possible, we see which of them is giving us the minimum cost, and that will decide our EOQ. So if you do that now, the annual ordering cost for the Q2 star, you follow the same approach. Is KD over Q, K is 100, D is 1,000 over Q, Q in this case is 142.86, and that result gives you 699.99. Then you'd go again, annual purchasing cost, which is DC, and our D in this case is annual demand, which is 1,000. C in this case is the price at which EOQ2 was admissible, and that price was 49. So make sure you are using the right price. If not, the answer will not be right. So you have 49 there. Then you have 49,000. Then annual holding cost half Q times H, and that will give you half Q is 142.86. H is IC, I told you, and I is 0.2 times C. The price at this EOQ for 2, which is admissible, is our C is 49. So that will give you 0.2 times 49, and that's how they got this 9.8. So you have 0.2 times 49, which is 9.8. And based on that, you have this result. Now you can add all these costs together to get the total cost of buying 142.86. So if you now check which of these total cost is giving you the minimum cost between 50,288, because we want to minimize the total cost of managing the inventory, depending on this quantity we are buying. So if you buy 300, the total cost of holding and managing the inventory is 50,288.33. If you buy 142.86 boxes of floppy disk, you have 50,400. So the one which is cheaper if you check it here, is to go ahead and buy 300. Even so, already you can see that EOQ for 2, which was admissible, is not even the best. So it means that you going for the minimum at the cheapest price is the best, because at least it gives you the minimum cost, which is 50,288.3. So based on this, you can already now conclude that the number of orders to be placed should be what? 300. And that will be your answer to the problem, because that's the one that gives us the minimum total cost. And that is the EOQ. And that's how you answer the first question, where they're asking you, how many boxes of this should be ordered? So the number of boxes of this to be ordered must be what? 300 boxes. And that's why they said Q3 star is the one which is minimizing the total cost, and that will be the EOQ. In terms of the number of boxes that should be ordered. Then the next question which was asked To answer that, how many orders will be placed annually? That is the number of order, which is EOQ, which is D over EOQ. Since now you have known the EOQ to be 300, then you can say D, which is 1000 over EOQ, which is 300. Then the number of orders will be 3.33 orders per year if you press calculator. Then the last question which was asked here is, what is the total cost of meeting the accounting firm demand? So already we have calculated the total cost that give us the minimum, the total cost of the queue that they give us the minimum total cost. So that total cost is 50,288.33 because it's a summation of your annual holding cost plus annual purchasing cost plus annual holding cost. And that gives us 50.28833. So you can already conclude that the total cost of managing that inventory to be ordered is 50,288.33. And that is the answer to all the questions in the problem. And another question which you can be asked, when should they reorder? You can also be asked questions in line with this in terms of when should they reorder if the lead time is 0? And you remember for that case, it's similar, it's synonymous to what we did from our EOQ, which is reorder point at lead time being 0 is EOQ over D. Then that one you can do it and determine that. Or the question can also ask you, when should they reorder if the lead time is maybe 3 weeks or 5 weeks? Then it talks to all those case 1 and case 2. So those questions can also come here because those determining the reorder point using the case of 0 lead time or non-zero lead time can also come here using the same approach. So you can also have those additional questions. Does that make sense up to this far before I show you some exercises to try on quantity discount model? Thank you. I'm waiting for people to respond. Please respond. Lindiwe, I hope it makes sense. Mwapelwa, I hope it makes sense. Thank you. I think everybody's sharp. Okay, good. So let me show you some tutorial questions because when we finish one concept, I always want to show you tutorial questions so that you see in the test, okay, this talks to this scenario, I know how to deal with it, following the same principle. So let me stop sharing before we go to the other inventory models. Then you can see the questions that talk to what we have said now in the book that you must try. So what we are doing actually is in section 15.3 in the ebook. So you can try question number, if you go to page 864, following the same principle, you can do question number 1 now. You can see they gave you a quantity discount table. Following the same principle, you must be able to do those questions as there now. Question number 1. Coming. So try question number 1 at home. Question number 2, you must be able to also do that now. Then question number 3, it must be your friend now. 1, 2, 3. Then number 5, but leave number 4. Just use information number 4 to the scenario number 4 to do number 5. So 1, 3, 5, because 4 and 5 is linked, but we are more interested in 5 where you are giving the discount information about that. And you can see that question is talking about how they know how many thermometers should be ordered in hospitals. So you can see this thing is very, very powerful. You can be inventory manager in any organization. I've got a master student of mine who is also looking at issue of expiry specimen tubes, which is used in the lab. So he's also looking at maybe applying some of this inventory concept to be able to see they actually, if he's first trying to investigate the root causes of why are they having expiry tubes, because when those tubes expired, then it's costing the organization a lot of money because they're going to lose those expiry tubes. And most of the time, the hospitals return it back to, I think, that particular unit that is procuring in those expiry tubes for the public hospitals. So he's looking at the root causes and trying to come up with the best inventory model and inventory solution in terms of helping them to know how much to stock so that they are not overstocking or understocking. Because when they are overstocking now, because the specimen tube has got shelf life, is expiring. So I'm just saying all these things just to tell you how important this subject matter is. And that there's these things, some students are even doing it for their master's study, mastering that and focusing on that as an inventory controller in a particular organization. So I hope that makes some sense to you. So try 1, 3, 1, 2, 3, 5. 1, 2, 3, 5. So I will leave you with that. Let me see, is there any other one I missed? Please don't leave those things to the end. Do it now. Before the end of the week or maybe weekend at the latest, do all those things so that you have mastered the concept. When it's time for summative test, you are just revising. Then you have more confidence. So I think with that, we are good with quantity discount model. So I'm going to stop sharing, then let's look at more inventory models because we still have 2 to 3 more to go. So another one, like where I told you, we are not going to be doing the proving because we've understand the whole synergy based on how all these inventory problem work. Because at the end of the whole day, for any kind of inventory model, we are just asking ourselves what must be our EOQ that minimizes the total cost of managing the inventory. That's the whole thing. But it's just that the attribute of the inventory from one organization to the other differ depending on the context of the kind of operations they do there. So depending on the organization and the nature of, like we've seen with the quantity discount model, where maybe supply is offering discount, you go for quantity discount model. So all these things, you must know them now and be able to use the appropriate inventory model to solve inventory problems and help in terms of managing inventory. So the next inventory model is continuous rate EOQ model. Continuous rate EOQ model. And when we talk about that, actually is the same thing as, I can type it on the chat for you. We always call this model as, can also be referred to as production consumption inventory model. And I will tell you when do you use this inventory model. I think calling it that way on the chart, I think that one is straightforward. Call it continuous rate EOQ model. It's premised on also the EOQ concept, but it's just that you only use this model as the name implies, production consumption EOQ model. If your organization, please listen carefully, if your organization, they produce final product for customers, but the inventory items required maybe that they need to assemble together to produce the final product is also being produced internally. In that case, it means that anytime you deal with that kind of problem, you are dealing with production consumption inventory model. Because that organization, maybe they've got another department which is dealing with the production of the inventory items, or they've got another production plant which is closer to them, which is part of the organization, working on producing the inventory materials, which is being consumed in the main manufacturing plant to produce the final product. Anytime you have that situation, and you want to manage inventories in that organization, you must use production consumption inventory model. So who can give me an example? Have you seen an organization like that? Have you come across one? Have you seen such situation where the organization, they produce final product and the inventory materials they use to produce the final product is being produced internally, maybe by one of the organizations, one of their subsidiary organizations? Have you come across that before? Have you seen that before? I see people are quiet. Molitani, let's hear from you. Have you come across that before? Molitani? Molitani is quiet. Okay, no. Okay, it's fine. So I see. No, sir. Okay. No, it's fine. So there are some organizations, I'll give you some examples. Think about it like all these automotive manufacturing plant, like Nissan manufacturing plant, for example. Some of them, they've got, don't forget to produce the car. There are various components that are assembled together. So you find out that for some of the components that needs to be assembled together, Nissan has got some other organizations. Fine, they are not located in the main manufacturing plant, but they are part of the organization which is producing the component and now feeding the main plant. So anytime you have that situation, it means that, as the name implies, you are producing you are producing inventory that you consume to produce the final product. That's why we call it production consumption inventory model. You produce the inventory you consume to produce the final product. So I hope that makes some sense to you. So that means anytime you have that situation, you are dealing with production consumption inventory model. And what I'm saying now, you can do your research and try to find out which organizations usually have that. I can leave that with you, that you have come across, whether manufacturing, and you see that actually in manufacturing organizations. So you can try to explore which manufacturing organization in South Africa has that. I'm leaving that with you as an assignment and explore. So how does this work? Just to help you, it means that I'm not going to take you through the formulation. We just go through the relevant formulas that we want to calculate. The question is, which you can be asking the test, is what is the optimal run size? Meaning that you want to know at what rate should you produce inventory, because you are producing to consume the inventory, so that you don't overproduce inventory, which will now be in excess. Then if you produce more inventory items, which is not needed in the main manufacturing plant, then you are having excess stock, which is waste from lean manufacturing. So what is the optimal run size, which is more like your EOQ, economic order quantity? But in this case, it's not order quantity, it's more like economic production quantity, because you are producing to consume it. So you look at economic production quantity and the same thing as saying optimal run size. So the formula for that is this formula you are seeing. You can derive it, but we don't have time to derive because we are just trying to find out what is the economic production quantity that minimizes the total cost of producing and holding the inventory between the producing organization and the consumption organization, which is consuming the inventory being produced for that same organization. And that means the formula is square root of 2kd R over H into bracket R minus D. So what is our K? And you can see it like the formula is the same thing as 2kd over H is more of like your EOQ in terms of square root multiplied by square root of R over R minus D. So you can take any of this. So EOQ is square root of 2kd over H. So any of these two formula is still right, anyone you want to go for. So what is our K in the formula? K is still K now in this case, because you are not ordering, you are producing. So this is talking to, in the scenario you see, you'll be given the cost of setting up the production run, because you are producing to consume the inventory. So in this case, you are not ordering. So K in this case is the cost of setting up the production run. So you see in the scenario you are given. And H is the cost of holding 1 unit of inventory item from the producing organization if the main manufacturing plant is not consuming everything. Then D is the annual demand. Then what is our R? Our R is more like the production capacity. The production capacity R, if you check it carefully, you see that the CR is more like what is the production capacity of that organization producing the inventory, in terms of saying how many inventory items can they produce per hour or per day. So in a scenario when you read that, you must read that as R. So let's just look at an example and see how we use. And don't forget, before we look at an example, if you know EOQ now, economic production quantity, the next question which you can also be asked is, what is the number of production that needs to be made maybe per year? What is the economic production quantity, which is the optimal run size? That could be the first question. What is the number of production? How many times should we produce per year? In terms of how many times should we run the production per year, which is more like your number of orders? And what should be the time between between one production run and the next production run? That is your the other point. So those are the possible questions you can have in the test in line with this. So let's look at an example, then you see how this works. You look at this scenario, it's saying Macho Auto Company needs to produce 10,000 car chassis per year. Macho Auto Company needs to produce 10,000 car chassis per year. Remember we said D is the annual demand, so they want to produce 10,000 car chassis per year, so that means our D is 10,000, so you write it down. So you can see that's why they said these 10,000 chassis per year. So I hope you have noted that. And you are told that each is valued at $2,000. So each chassis, which is the price, which is more like your C. The price of the chassis is $2,000. So that means your C is $2,000. So you can see that as your C in terms of the cost of that chassis item they are producing that is produced to be consumed. And they told you that it costs $200 to set up a production run. I told you K in this context is the cost of setting up the production run because we are producing to consume. So that means your K is $200 per production run. So you note it down. And they told you the annual holding cost is 20 cents per dollar of the inventory. So it's more like 20 cents multiplied by the price of the inventory item. So you can see H as more of the IC again, which is like 25 cents per dollar value of the inventory. So what is the price of the inventory multiplied by this 25 cents? So that is what gives you the holding cost in this context. So holding cost is more like your IC, which is 0.25, 25 cents. If you convert it to a dollar, is 25 by 100, because you have 100 cents in a dollar. So you have 0.25 multiplied by the price of the inventory item, price of the chassis is 2,000. That will give you 2,000. And that means each in this case is $500 per chassis per year. So then they told you another thing. I think I skipped something. They said the plant has the capacity to produce 25,000 chassis per year. I told you R is the production capacity per year. So R is 25,000, so you write it down. R is 25,000, you write it down. Then in that case, R is 25,000. Then you can now, the first question which they're asking you, determine the optimal production run size, which is the economic production quantity. So I showed you the formula, which is square root of 2kdr over h into bracket r minus d. You can take any of these formulas, so I'll go with the first formula. So if I take that formula, 2k, that is 2 times k, which is 200, times d, which is 10,000, times r, which is 25,000, over k, which over, what do you call it? Over h, sorry, it's over h, which is 500. You remember, if you go back to the formula, is H there over H, which is 500, into bracket R minus D. R is 25,000, then minus D, which is 10,000. Then you find the square root of everything. If you do that, the optimal run size is 115.47 in terms of how many units of chassis you must produce. So in that case, you can round it up to the nearest whole number if you like, even though because chassis is like a whole chassis, you cannot have fraction. You can round it up to become 116. But in the textbook, they didn't round up, so you can round it up. But if you use it like that, it's still not a problem. Then you can take, that is the answer for the first question. So the answer for the optimal production run size is 115.47 production run. In terms of 115.47 chassis, that's the number of chassis you must produce, which is approximately 116 chassis that you need to run for any production run in terms of the economic production quantity. Then the next question is how many production runs should be made each year? So that is like your number of orders. So you can also calculate this. If you calculate this, this will give you, it's like your D over EOQ, remember? So D in this case is 10,000 over the EOQ, which is 115.47, 116 if you have approximated. Then that would give you 86.60 production runs to be made per year, which is approximately 87 production runs, because you cannot have a fractional. You can leave it as a fractional because you can decide not to produce for the whole production, you just produce for a particular period. So you can leave this one in decimal because it can have a fractional production run, but in terms of chassis, you can round it up to the nearest whole number. And that will be the answer to this problem. And there could also be a question in terms of what is the time between each production run. That will give you EOQ over D, which is 115.47 over 10,000. And any answer you get will be in year, then you can convert it to weeks or something. So any question with this, does that make sense? Does it make sense? Those are the possible questions you can have under this. Thank you, Lindy. I'm waiting for other people to respond. Thank you. Good. Perfect. Good. So in this case, let me also show you questions that talks to this, because when we do one concept, we reflect and we go and look at how the question is, the possible questions that you have for this in the book to practice. So if you go to page 868 in the ebook, page 868, you can try question number 2 and question number 3. Then also you can try question number 4. And this question number 4 is very interesting because in some cases, some people might use this concept to ask themselves, because question number 4 is trying to look at a situation, and some organization does that to say, is it really economically viable for us to produce our inventory in-house, or we should just buy from suppliers? So that means they're going to use if they want to know whether it's economically viable, they go and calculate how much should they produce internally, what is the cost implication for that, and the cost of setting up the plant and all those. And maybe they can calculate that in terms of the cost they will incur for producing and holding inventory and managing that for the next 5 years. And they would now also look at what is the cost of if they don't want to produce in-house, what is the cost of maybe placing order and managing the inventory they are ordering for the next 5 years or for the next 10 years for a very long period of time. Then they can compare between the two options and now ask themselves which of the options is the best. So that means they are using the EOQ approach if they are buying from supplier to do the computation, calculating the EOQ, the number of orders to be placed per year, depending on the number of years they are running the analysis for. And they do use the production consumption model to assume that if they are producing in-house and they have get all the parameters in line with the scenario we have been seeing, what is the economic production quantity, how many production should they make per year for that inventory item that they want to consume to produce the final product, and what is the total cost of doing that. And let me quickly say this. Another question which you can also be asked, because also here, for the production consumption model, you need to also calculate the total cost you are incurring at that optimal production run quantity. So you can go and calculate what is the total cost over the number of production you're going to make for the next 10 years. And they are now trying to check between the two options. The total cost of buying from suppliers for the next 10 years and the total cost of maybe producing in-house for the next 10 years. Which of them is cheaper? And that with that, they're able to arrive at the decision of the best way of getting the inventory, whether should they produce it in-house using the production consumption EOQ production consumption model, or they should get it from supplier. And that is the kind of question you are seeing question number, what do you call it, in the question that I was showing you now, which is question number 4. So that means you are going to go and use the normal EOQ to do the normal computation, and you use the production consumption model and the relevant parameters associated with that to do the the optimal production run size, the number of runs and all those, number of production runs per year, and the total cost for that economic production quantity, and now compare the cost. And the one that give you the minimum will tell you whether the organization should produce those inventory items. Should they purchase it in terms of ordering from supplier, or should they manufacture it on their own using the production consumption EOQ model? So also try that question. So I've given you some tips already. And if you want to calculate the total cost, let me just show you the formula you use. I think I almost forget that because the question can also ask you what is the total cost at the optimal production run size. The formula you use to calculate that total cost is here. I will show you now. The formula which you use is here. HQ into bracket R minus D over 2R plus KD over Q. So if I want to know what is the total cost I will incur at the EOQ or any Q that I decide to produce, so you use that formula. So if you want to calculate the total cost of producing that economic production quantity, that means the Q is becoming EOQ. And the Q might not be EOQ, if it's any value, depending on how many you want to produce, you can determine the total cost. And if you want to see how sensitive is the number of Qs you are producing from the EOQ, like we did with the EOQ, you can always experiment using this formula, like we did with the EOQ. So please take note of that also. Does that make sense? And that is the formula, HQ into bracket R minus D over 2R plus 2KD over Q. So you know all those parameters, you just plug and produce. Does it make sense? Because like I said, you can be asked to find the total cost at the optimal production run size. So you use that formula. The Q in that formula is becoming the EOQ. Or if they give you a Q of interest in terms of how many you must produce, then that value is what you use in the formula. Then the other K will be the setup cost and all those, D is the annual demand and the likes. R is the production capacity of that organization which is producing the inventory item in-house. So you know the other parameters. Does it make sense? Because that's also another question you can be asked. Am I making sense? Please talk. Okay. Nsana, does it make sense up to this stage? Lindiwe, please respond. Morena. Nkosazana, I hope we are together up to this stage. Okay, good. So I think with this, we are good. So try question like I told you. You must do question number 2 under production 2, 3, and 4. Make sure they are your friend. Now let's move on to the next one. We are almost getting there. So what I want us to do today, at least if we can finish all the inventory models, because I don't want us to start a fresh one. Let's do all the inventory models on the deterministic inventory models. You will finish it, we'll call it a day. Then we start the probabilistic inventory model on Friday. We see how far we can push, but I think by Friday we would have almost pushed everything. Then we'll now finalize. If we're not able to finalize probabilistic inventory model on Friday, we'll finalize it and look at the last module, which is network model, which is just one concept, so that by Tuesday we are done with everything. That's the plan. But for today, I don't want to rush you. Let's do, because we still have 2 more inventory models. And I just want us to do those 2. Then when we finish it, we would leave, because I don't want to start a new concept. It's a lot of things we have said already. Let's go and digest that and practice those questions. Then Friday, we start on a fresh slate. So that at least we are not just doing too much and it's just a lot, then we get confused. So let's do everything under deterministic inventory models. So we are left with 2 more inventory models. Then we call it a day for today. So another one which we need to talk about quickly is economic order quantity model, another inventory model. So now you see, for those people that think they know inventory management, you see that you only know little, because inventory problem from one organization, depending on the attribute they exhibit, can differ based on all these things I'm saying, and that will influence what type of inventory model you're supposed to use. So with what I'm teaching you now, it will make you I'm not saying you'll be 100%, because there are more inventory models, because the ones I'm doing now is more of the core ones, the basic ones. But if you read more articles in the literature, you find more interesting inventory models, which is bringing more real-life operational issues, which is now modifying the EOQ further. So, but at least we are trying to cover the core ones that we know in our organization we used to experience in most of the manufacturing service organization in South Africa you used to experience. But with this, at least you have a very good knowledge of inventory and how to manage it. So the next inventory model is economic order quantity model. But if you look at all of them, they are premised on EOQ. If you can look at all of them, it's just that we modifying EOQ to talk to the inventory management context or inventory operations context of that organization. So the next one, like I said, is the economic order quantity model with backordering allowed. With backorders allowed. So if you look at our normal EOQ, remember one of the assumptions of the EOQ before we went on break is that shortage is not allowed. Lead time is 0. And we also look at the situation of if lead time is non-zero, how do you deal with it, which results into those 2 cases. But how about if an organization is allowing backordering, meaning that they know that that inventory item, they can run out of stock for it for some period of time. And maybe they've agreed with their customers to say, owing to the element of saying we are going to be out of stock for some inventory items, then that means we are going to backorder your customer demand, and customers have also agreed. if there is a mutual agreement between customer and the supplier, which is the person buying inventory to produce what the customer wants, that barcoding is allowed, then in that case, the EOQ model that you must be using will be EOQ model with barcoding allowed. But if barcoding is not allowed, then you must use the normal EOQ in line with any of these other inventory models we have talked about, and selecting the right one in line with what I've said so far. But if barcoding is allowed, there's a mutual agreement, then it means that EOQ model with barcoding should be used. And if you look at the behavior, it means that when you consume, just to show you how it works, when you buy Q, you start from 0, you place an order for Q and the Q arrives, you consume it, you run out of stock because now you are getting to 0, but you need some items to produce, but you are running out of stock. That's why you are getting to the negative Q. Depending on the time you run, depending on how many quantities that is needed until the order arrives. And as soon as the order arrives, and actually what you are seeing here, you go run into Q, meaning that you're having a shortage. Meaning that you have a shortage, you run out of stock, you are short of the inventory you require. So you are getting to negative Q. So what is that shortage before the next order arrives? Then when the next order arrives, now you shoot back to Q. And maybe the way you're also ordering, you know that you run out of stock. So depending on the shortage you experience, when you place the order, you've already accounted for that into it so that you can already shoot back. Any order you place is accounting for the shortage and shooting you back to Q. Then you consume again. The behavior continues like that. You run out of shortage, you shoot back to Q and like that. So that's the behavior. So the question now is, what must be the EOQ that you need to order in such a way that anytime you place an order, is already accounting for the shortage that you are experiencing, as well as making sure that you have the EOQ that you can consume over a reasonable period of time before you place the next order to deal with the shortage and what is always required to be used on every ordering period. If you want to calculate that EOQ for that, that is Q star, which is EOQ, and the formula is square root of 2KD. We are not deriving, but just to show you the final formula, we use it in an example. Square root of 2KD into bracket H plus S over HS. Or you can read it as this, but I will just leave it as this because I'm using this formula straight in the computation. Square root of 2KD into bracket H plus S over HS into bracket, that is into bracket raised to power f or square root of half. So this is the EOQ. And A, you know, H is your ordering cost, D is the annual demand, K is ordering cost, S in this case is talking to this shortage because you run out of stock from 0 to negative. So what is the shortage? That is the S. So we are going to see, and that is talking to the shortage cost per unit. What is the cost associated with, are you allowing shortage per unit? So that is your S. So that is your Q star. And what must be the maximum shortage? What must be the maximum shortage so that when you place an order, it's catering for the shortage and it's giving you a reasonable queue. So the maximum shortage that you must allow based on the order you would be placing, so that when it arrives, it take account of the shortage and it give you a reasonable EOQ that you can still use before you run out of stock and place another order again. Is represented by M star, and the formula is square root of 2KDS over H into bracket H plus S. So that raised to power half is the square root. So that is the maximum shortage. So those are the questions you can be asked here. What is the EOQ? What is the number of orders? What is the time between, what is the other point in terms of time between placing orders? And that is just the square root, or that is your EOQ over D, you know, all those formulas. And what is the maximum shortage? You can also be asked that question. So all those questions are the questions you can get here. So the first question, like I told you, can be asked, what is the EOQ? So let's look at an example and what is the maximum shortage using any of those formulas. So let's look at an example and you see how I'm seeing that this problem, I must use EOQ model with backordering allowed. So you see how I'm seeing that now. They said each year, Read the scenario. Each year, the small town optometry clinic sells 10,000 frames for eyeglasses. Each year, the small town optometry clinic sells 10,000 frames for eyeglasses. So that means the annual demand in that question is already given as 10,000 frames. So that means your capital D is 10,000 frames. When you read the scenario, note the parameter given. And the next statement is telling you that the clinic orders frames from a regional supplier. Remember I told you like what my student was, one of my master students is doing. So like he's looking at actually there is a supply organization, they are supplying specimen tubes to all these hospitals. So it's just that now the problem they're having now is when they supply, sometimes the hospitals are returning to say some of the tubes are expired, which is like a loss for them. So he wants to now come up with an optimal inventory management to minimize such occurrence. So something like that. If you look at this, so the question is, what should be ordered in terms of the specimen to specialist, since it's a perishable item, because after some time the tube expires. So if you look at this, they are saying here, the clinic orders frames from a regional supplier, which charges $15 per frame. So that means the price of each frame is $15. So which is your C. And they told you that each order incurs an ordering cost of $50. So that means your K is $50. You take note of that. And they told you that small town optometry believes that the demand for frames can be backlogged. Already when you are hearing backlogged, I told you that means backordering is allowed. So that means I see that in this problem with this statement is dealing with EOQ with backordering. So that means there's a mutual agreement between the customer and the supplier that the demand for this frame can be backlogged. So that means to solve this problem, I need to use what EOQ model with backordering allowed. I can already see that. And they said, and that the costage of being short of one frame per year is $15, which is maybe cost, the way they cost that is a function of if they are not able to supply their customer, what is the cost of loss of customer goodwill. So some people calculate the shortage cost from that concept. And they were able to use cost accounting to arrive at that, and that gives them $15. So in the test, you'll be given that parameter like this, but if you want to apply it in practice, you have to look at it in terms of loss of future business and compute that using the costing accounting principle and work it out per frame, depending on how many shortage you foresee. Before now, the order is available. That will give you that cost of shortage per unit item per year. And now they told you that cost of shortage is $15, and that is S. I told you, small letter S. And they told you that the annual holding cost for inventory is 30 cents per dollar. Per dollar value of inventory. So you're also looking at your H as your IC in this case. And that is 30 cents times the price of the frame, which is 30 cents, which is 0.3 times 15. And that will give you H. The first question is, what is the optimal order quantity? And I told you if you want to calculate the optimal order quantity, use this formula, which is Q star, which is square root of 2KD into bracket H plus S over HS. So that's the first question, which we're going to use that and plug and produce our parameter into the formula. The second question, what is the maximum shortage that will occur? So which is M star. Maximum shortage. What is the maximum shortage that will occur? So maximum shortage is Q star minus M star, sorry. Maximum shortage is Q star minus M star. M star is the maximum inventory level. In terms of the maximum inventory you can hold before now you run out of stock. So maximum shortage is Q star minus M star, because if you look at it, this is your Q in terms of what you are ordering, then your M in this case is just talking to what the inventory you are holding before you run out of stock. So that means Q minus M. If you look at Q as everything here, and M is the inventory you are having that will be consumed over time before you run out of stock, then Q minus M now is the shortage. So M star is the maximum inventory you can hold, which will be consumed. So you can also be asked that question, which is what they're asking here to say, what is the maximum shortage? So it's Q star minus M star. What is the maximum inventory level? That is the M star. That means before I can calculate maximum shortage, I need to calculate the M star first. Then after knowing M star, I know Q star, then I can calculate the maximum shortage, which is Q star minus M star. So if I do that now, based on the parameters given, K is $50, D is 10,000. I told you H is 30 cents of the price of the frame. So that is 0.3 times 15. And your H is $4.5 per frame per year. The shortage cost, we have seen that to be $15 per frame per year. Then Q star in this case now, which is the optimal order quantity, using that formula 2KD into bracket H plus S over HS. So that is 2KD, 2 times 50 times K, 2 times K, which is 50, times D, which is 10,000, 2KD into bracket, let's see the formula again, H plus S. So let's see, how did they get 19.5? H plus S, H is 4.5 plus S, which is 15. So 4.5 plus 15, that gives you 19.5. That's how they got 19.5. But if you write it out, you can see how they arrive at that. Over HS. And everything is inside the square root. Over HS, H is 4.5, then S is 15. Then find the square root of everything. Then your Q star, which is the optimal order size, is 537.48 frames. If you like, you can approximate it to the nearest whole number because you cannot have a fractional frame. But in this case, they leave it as it is. Then the next question, they ask you for the maximum shortage, but before you can determine the maximum shortage, you must find the maximum inventory level, which is the third question. So you find M star, which is square root of 2KDS, square root of 2K, K is 50, D is 1,000, 10,000, then S is 15, over H into bracket H plus S. H is 4.5 into bracket H, which is 4.5 plus S, which is 15. Then that is everything inside the square root. If you find the press calculator, that will give you 413.45. If you like, you can approximate it to the nearest whole number, which is 414, because you cannot have a fractional frame. But according to the textbook, they leave it like that. It's still not a problem. And from there, they got the maximum shortage. The maximum shortage, with, if you have approximated to the nearest whole number, that will give you 538 minus 414. Or use it as it is, which is 537.48 minus 413.45. And any result you get is giving you 124.03. So that means based on this, you can already say the maximum shortage is around maybe 124 because 0.23 is highly negligible. But if you approximate everything from the beginning, you get whole number for your maximum shortage already, because you just give you 538 minus 414. Any results you get will give you the maximum shortage. So any question with this? Does this make sense? Type or just respond. Are you happy? Good. So I'm just trying to see. Please let everyone respond. Thank you. Insana, does it make sense? Metlape, up to the stage. And you see, luckily for all this inventory management, It's not like deterministic where you compute a lot. You just read the scenario, identify the parameter, and use the formula, use the appropriate formula. Then you're fine. So I hope it makes sense. I think everybody has indicated. And question on that EOQ with backordering allowed. Try this at home also in the textbook. Try question number, go to page 872, 872. Try question number 2. Page 872, page 872, try question number 2. That's the only question you must try. Page 872, question number 2 on EOQ with backordering allowed. So I hope that makes sense. So I think with this, you have seen that. Now let's go to the last inventory model under deterministic inventory models. And if you look at all these inventory models we have been looking at, you can see that the demand for those items, they are known with certainty. So that's why all of them are solved deterministically, because they were giving you the annual demand. They tell you every year they require this amount. So that means on yearly basis, that demand is not changing. Or maybe on monthly basis, it means that every year the demand will be the constant. But if they are dealing with a problem where the demand is changing, maybe on an annually basis or monthly basis, that means annually the demand is not constant, it's changing. Hence, the problem is no longer deterministic, but is now probabilistic. And that's the one we'll be looking at on Friday. And how do you now, if you have that kind of problem, and that's actually what we see in practice, how do you know what to stock? Like I told you, with ShopRite, look at the inventory items that you have inside ShopRite. The demand for toothpaste on daily basis or monthly basis changes over time. So how best should they know what to stock so that they don't overstock on the stock? All those kind of problems we see on Friday. So and that's what I'm saying. Friday class, you need to be here. It's very, very important. So I think with that, let's go to the last deterministic inventory model. So the last one is the multiple product EOQ model. Multiple product EOQ model. Multiple product EOQ model. That's the last one. So if you want to just take water, you can take water. Just for you to rest a bit. I'm also trying to stretch. So maybe we can just stretch for 1 minute if you want to take water. So I know we'll finish around 8:30 or so, or maybe 8:40 or less than that. But at least if we finish this one, that's the last one, and I give you exercise, then I think with that, that will be enough for today because we've said many things. And with that, you can go and master what we have done today. Then we continue on probabilistic inventory model on Friday. But maybe if you want to take water, I'm just giving us 1 minute to rest so that I can also keep quiet and gain some strength for the last inventory model. We can now start. Let's start the multiple product EOQ model. Are we set now or you are still taking water? You can just respond. Are we still stretching our body? Sharp. Okay, good. Let's look at the multi-product EOQ model, which is the last concept for the day. So with the multiple product EOQ model, this is is a very important inventory model because if you look at an organization, you find out that what they are ordering from one supplier, inventory items they need to order from one supplier is not only one item. Am I right? Do you agree with me? It can be more than one inventory item. Thank you. So they might be from one supplier ordering maybe 10 or 5 different items with different demand. Then the question is, how many items should they order for each of these items? And how many orders should they make for each of these items on a yearly basis? And what I'm showing you actually is really the one which is even more applied realistically, because most of the organization, like I give an example to say, if you look at ShopRite, there are various items placed on the store. So when they want to place on that, they are dealing with multiple items. And you find that some of the items, they would have grouped it in terms of, for this set of items where we know we get all these items from one supplier. So when they deal with that problem, in terms of knowing what to stock, they are using multi-product EOQ model to know how should they order, provided that, but now don't forget the demand for those items are not constant, maybe on yearly basis. That's what now make it probabilistic and now make the inventory problem more complex, which we see on Friday. But if you look at that, like I was saying, a supplier, you might be buying more than one inventory item from a supplier. So, and if the demand is constant for those items, for those inventory items you are buying on yearly basis, then in that case, you can use the multi-product EOQ model to solve that problem. Meaning that you are going to, the way you do that, which I'm showing you in the slide, if you want to solve this problem where you're buying more than one item from the supplier, the first thing which you need to do is you need to determine the EOQ, the number of orders to be placed per year, and the total cost incurred for managing inventory item for each of the item. That's the first step. So you do EOQ individually, number of orders, and the total cost of managing inventory for each of the items. That's the first step. Then the next step for you to be able to come up with the best EOQ that minimizes the total cost, you go and check whether the solutions for the activity in procedure 1, check whether this solution, does it satisfy or violate the company's ordering policy in terms of total number of orders that should be placed in the organization per year. Because if you just make it open, because don't forget, placing an order, it comes with cost, like the ordering cost, like the cost of follow-ups, like I told you, remember all those costs. So every organization wants to minimize how many orders to be placed. So how should we strategize the number that we need to place in such a way that we minimize the number of orders placed, because we know we are incurring ordering costs, and we are able to minimize the total inventory holding costs. And that is what the organization come up with to say, how many orders should we place per year? So we've got a policy. So the question is, which is talking to the next statement, which you are seeing here to share, is that they check whether the solutions that they've got in step number 1, does it satisfy or violate the company's ordering policy in terms of how many orders should be placed per year, and what is the monetary value of them holding inventory in their warehouse? So they do those calculations and check. If the answer they got from procedure 1 doesn't violate, then that means that is what the step 3 is saying. That means the solution they obtain in procedure 1 is the optimal ordering policy. That means they must proceed to go and do order those EOQ per order, and they must order based on the number of orders, those EOQ, and the total cost they will incur is that result they got in step 1. But if no, if the result they are getting in terms of number of orders or monetary value, if it violates the ordering policy of the organization in terms of those two items, then they need to adjust the EOQ to make sure they need to adjust the EOQ to make sure that they satisfy all those company ordering policy in terms of the number of orders. So they've adjusted the EOQ in such a way that the number of orders the organization wants is what is placed. So what will be the new EOQ? They calculate that using this formula, which is EOQ of K equal to square root of 2dk into bracket K plus lambda. This lambda is like Lagrangian multiplier. If you look at it, because this formula was derived using the Lagrangian multiplier, but I'm not going to take you through the derivation. So just see it as lambda. Don't let me stress you that much. See it as lambda, then over ICK. Everything is inside the square root. But this lambda you obtain it using this formula, which is I into bracket 2n squared into bracket summation of square root of dk times ck squared minus k. So I will show you how you use this formula when we get there. Where n in this case is talking about, remember the organization has got some policy, ordering policy. What is the number of orders that the organization desire? So you need to go and find out from the organization policy how many orders would they always like to place. If you want to apply this, you take note of that on a yearly basis. And that's what you use here so that you know how to adjust the EOQ. And what is the ordering cost per unit product? And you find the average of that, and that will give you your K here. So you find the ordering cost of each product, then you find the average. Any result you get, it will be this capital K. So I will show you how we do that. And after you do that, you get your lambda after you have plugged that, and you can get your EOQ for each item that you have adjusted. You see how we are doing that. That is if your answer is no. And this one talks to case 1. If your answer is no, that means it's violating the first case where maybe the number of orders you got based on the step 1, it violates the number of orders that the organization wants, which is talking to the first case Roman figure 1. So you use this formula to adjust the EOQ in step 4. But if your answer is also no, for you to get, if your answer is also no to option number 2, that means your monetary value is higher than what the organization wants, depending on the amount of inventory you want to hold based on the result of step 1. You calculate the adjusted EOQ using this formula, which is EOQ for K is square root of 2dK over I plus lambda, then multiply by CK, everything inside the square root. Then lambda in this case is K over 2B squared, K over 2B squared, then into bracket summation of square root of dkck squared minus I. I will show you how this works. B in this case is talking about what is the desired money in terms of the monetary value that they want the average inventory that they are holding the organization to be. What is the desired amount of money that the organization want in terms of tying their money to in terms of inventory. So in the question you'll be given, and I've told you K is the average ordering cost. You sum all the ordering cost, then divide it by the total number of products for that you have the ordering cost for, and that will give you the average ordering cost, which is capital K. Then you can plug it into this formula to get lambda. When you get lambda, you can now use it to calculate EOQ for each of the items. So let's see how we use all these formula depending on any of this case, following the steps. So let's look at an example. Don't really worry much about the formula. You see how we are using the formula now when we start the computation using the formula. So let's see how this works. So look at this example. And also what I want to say to you, I think there's one, okay, maybe when we get there, I will just ask you to confirm that result, because I think there was one mistake in the computation. I remember some student used to tell me, but you try to correct it at home. You verify the answer. If it's not the right answer, you can change it and use it to edit the computation. But I just want to explain the steps, following those steps that I've explained. Then you follow that step to the letter for all the tutorial questions I will give you. Then we'll call it a day. So let's look at this example. They said Home City Appliances has 3 types of TVs delivered from Springfield TV. So you see, I told you when you're having one supplier supplying more than one product to an organization, which is the customer, then in that case, you are dealing with multiple product EOQ models. They are supplying 3 types of TV to that customer. And they said the figure below gives the annual demand, the unit purchasing cost, and the annual holding costs, as well as the fixed cost of ordering a product and the fixed cost of placing an order for those 3 products. So if you can check it, they gave you those information. Look at the annual demand for product 1. For product 1, based on the annual demand, they know which is constant every year is 12,000. For product 2 is 1,200. For product 3 is 120 in terms of what they require annually. The unit cost of buying each item is the same. But don't forget, in some situation, the unit cost might not be the same. So don't always think it will be the same. But in this question, the fixed cost for product 1 in terms of the price of buying TB for product 1 is 500. Product 2 is also 500. Product 3 is 500. Then the holding cost is also the same. And in some cases, maybe the product have special items to hold them. Product holding cost might not also be the same. Maybe for some items, it might be the same for some. It might not be the same for all. But luckily in this question, holding cost is the same, which is 0.2, 0.2, 0.2. And they told you, and those things are in dollar. Then the product order cost, which is the price of buying the item, is $1,000 each. So in some situation, the price of the product might not also be the same. They might be unique. But for this case, they are the same. Take note. But it doesn't mean every time it will be the same. That's my argument. So look at the first question. The way this question is being asked, it talks to all these steps that you have if you want to know the EOQ that will make you achieve the ordering policy. All the questions that they're being asked, they come in this order of the steps you must follow. So if you look at the first question, it's talking to procedure 1, which is saying, determine the EOQ, the number of orders placed per year, and the total cost incurred per year for each TV. Remember, that is procedure number 1, because procedure number 1 is saying, find the EOQ, the number of orders, the total cost of managing the inventory item for each product. So that talks to step 1. So let's do that. We know how we do that using the EOQ formula. So don't forget, in this case, holding cost here also, they said annual holding cost is a percentage, they express that as a percentage of the purchase cost. So that's why you see they are not putting the value in dollars. So it's 0.2 of the price of the item. So that means H will be like your IEC, which is 0.2 times 1,000. Take note of that. I also wanted to echo that. So that is the reason why you see when I do that, I said for product 1, EOQ is square root of 2KD over H. H is IC, like I told you. Then in this case, let's see quickly. The product order cost, sorry, I'm looking at the product order cost is 1,000. So that is your K. But the unit cost, which is C, in terms of cost of buying the product, is 500. Don't forget, product order cost is the K in terms of ordering cost, please. I think maybe because I'm too tired, I'm now mixing it. Sorry for that. So in that case, we have square root of 2KD over H, and H is IC. So that will give you 12 of, so we start with product 1, use the formula. So that will give you square root of 2 times K, which is 1,000, because ordering cost for product 1, we have seen is 1,000. For product 2 is also 1,000. And for product 3 is 1,000. So you just plug and produce 2 times 1,000 times D, annual demand for product 1, go and check it in the information given is 12,000. You plug it in there over IC, which is H. That will give you 0.2 for the product 1 times C. Price of the product 1 item is 500. And that will give 0.2 times 500. And that gives you EOQ for the first product 1 is 489.898. You leave it. If you like, you can round up to the nearest odd number because we are dealing with TVs, but we are leaving it like that. Then you calculate the number of orders. Remember, we need to calculate EOQ, number of orders, and the total cost for each product. So number of orders is annual demand over what? EOQ, which is Q. So if you do that, that will give you annual demand for product 1 is 12,000 over EOQ, which is 489.898. And that gives you 24.495. You write that down in terms of number of order. You calculate the total cost of managing the inventory item for product 1. Remember, it's KD according to our derivation of EOQ is KD over Q multiplied by QH over 2. Remember, QH over 2 is the total holding cost, and H in this case will become IC, like I told you. So that's why you see I was writing QIC over 2 because IC is H. Take note. So if you plug your parameters into the formula now, that will give you K, which is 1,000 for product 1. Annual demand is 12,000 over Q, which is EOQ, which is 489.898. Then Q, which is 489.898 times I, which is 0.2 times C, which is 500 for product 1 over 2, plus DC, the annual demand for product 1 is 12,000, multiplied by C, which is cost of the item for product 1 is 500. So I leave this with you. You can press the calculator and confirm your answer. So you must finish it from here. You follow the same thing for product 2. You calculate your EOQ by checking what is your K for product 2. K is 1,000. What is your D for product 2? 1,200. I is also 0.2 and C is 500. If you follow the same principle for product 2, you get this result. You get this result, and you can get your TC also from there, following the same principle like I did with product 1. And you follow the same thing for product 3 by checking what is the annual demand for product 3, which is 120. What is our C is 500. I is 0.2 for product 3, and the K is 1,000. So if you do that, also find your EOQ number of orders to answer question number 1, TC, you get this expression. And you finish that to answer the first question. Does that make sense? Type Y if it's still making sense up to this stage. Does it make sense? Or maybe you can just use a reaction button.
It's too much to swallow, sir, but I think listening to the video once more maybe will make more sense.
Perfect. Because no, it's not, yeah, it's too much because we have a lot of parameters, like you're saying. So you just need to follow what I've said to the letter. Are we together there? But that's why we are recording this session. Mashlangu, Mashlangu, maybe you must, Mashlangu, you must, I see you are showing us that you're eating. Thank you for showing us the food. And me, I'm hungry now. Thank you. Thank you for that. So let's move on. So you do that. It's not difficult. You just follow what I'm saying to the letter. And after you have done that, in that case, we have answered the question A. Because the first question, if you go back to that question, they ask you to determine the EOQ number of orders and total cost for a TV. We have done that now. Then look at question number B. Actually, we are going to question B and C, which is talking to the next steps now. So they said, if the total number of orders to be placed per year is 20, if the total number of orders to be placed per year is 20, so you remember if you go to that step, They say you must go and check what is the company's ordering policy in terms of number of orders to be placed per year. And check whether your solution in A, if you add all the number of orders you are placing to meet the demand for all those 3 products, whether it doesn't violate the ordering policy. So, and that is what that question is now asking. To say if the total number of orders to be placed per year is 20, what is the EOQ and the number of orders for each year? For each for a TV that will satisfy this ordering policy. So let's try to see that question. How do we answer that? I told you to answer that. What you need to do, you need to sum all the number of orders that you have calculated for product 1, for product 2, and product 3, based on the result of your question number 1. Remember, number of orders for product 1 was 24.49. For product 2, it was 7.75. For product 3, it was 2.45. You sum that together, and that's what you see us saying here. Then you sum it and check. Look at the total number of orders, because that is saying this, that is the total number of orders you must place for those 3 products from that supplier to be able to meet that annual demand. If you check it, is it more than the number of orders required by the organization? The answer is yes, because we are getting 34.695, which is roughly 35. The number of the orders that the organization wants is 20. So that means the solution we got in step 1 is not the optimal EOQ, and it's not the optimal EOQ. So I need to adjust the EOQ to satisfy this 20. But if maybe the result I got here was less than 20, that means the EOQ that I got from step 1 is the best result. Take note of that. That's how you conclude. But in this case, this 34.65 is violating the number of orders, because this higher number of orders implies that there will be more ordering costs incurred by the organization. So the organization wants to lesser their ordering cost. Hence, they want an ordering cost less than or equal to 20. But this solution is giving us something more. So how do we now get the adjusted EOQ? That is where you go to this step and you use this the result of case 1, because case 1 is talking to you checking the number of orders desired by the organization. So if you want to find the adjusted EOQ, that's when you use this formula here. So you take this formula, because the number of orders is violating the desired number of orders required by the organization. So I'm going to take this formula now, and that's what you see us doing here. We take all this formula. Then now we go and find, to use this formula, we first start find lambda. So we need to find lambda using this formula, so that now we can plug and produce inside to get the adjusted EOQ for each product. So then we do lambda equal to I. This I is the average, because don't forget we have 3 products. So you need to go and check what is the I for product 1, for product 2, which is talking to what you have in this holding cost row, because that is the I, which is like the percentage of the purchase cost. So you find the average of this. You said 0.2 plus 0.2 plus 0.2, because there are 3 products divided by 3, it will still be 0.2. Any result you get is what goes into your I in the lambda formula, divided by 2. N, I told you N is the number of orders desired by the organization, which is 20. So you put 20 there, then you square it. Then this summation you are seeing is not difficult. It's a function of how many products you have. That's why it's summation. Then square root of D, dk, the K there is talking about maybe square root of D1 times C1. That means you are talking with product 1, plus square root of D2 times C2, plus square root of D3 times C3, depending on how many products you have. That's why you have summation there. So that means you are going to simplify this by saying that summation is becoming square root of D1. K is talking to how many products, where K is from 1 to N, depending on how many products. Square root of D1, annual demand is 12,000, times C1. What is the price of the item for C1 is 500, so you bring it. Then square root of D2 times C2, which is the demand for 2 is 1,200, times price of product 2 is 500 plus square root of D3 times C3, because you have 3 products. If you have 4, you continue. The square root of 120 times 500, then you square that, minus K. I told you this K is the average ordering cost. So you add also 1,000 plus 1,000 plus 1,000 divided by 3, that is still giving you 1,000. So any result you get is what you write down here, which is minus the average product ordering cost is 1,000. And if you simplify this gives you 2008.55. You can always confirm it in the calculator. And after you have got this lambda, we're almost there. Now you can because now you know the lambda, now you can now use this formula to find the adjusted EOQ. That will make sure that your number of orders should not exceed 20. So now you take the EOQ formula. You see that K there is talking about EOQ for K is talking about, like I told you, the each product. So K can be 1 to N depending on how many products you are ordering from the supplier. So that means you are dealing with EOQ for 1, where K is 1, equal to square root of 2D1 into bracket K plus lambda over IC1, meaning that you are dealing with cost of product 1 and EOQ for product 1, that is EOQ1. So if you do that now, that means this will give you EOQ1 equal to square root of 2D. The demand for product 1 is 1,200. K is 1,000 for product 1 because you're dealing with K for product 1. You go there, then lambda you have calculated, that's why you've calculated it first, is 2008.55. Then you can bring it here over IC1. I for product 1 is 0.2. Then C for product 1 is also 500. Then EOQ1, you see now it has been adjusted to 849 instead of what we had initially. If you look at our result for EOQ that we calculated for product 1, initially it was 489. But because we want to minimize the number of orders, you see EOQ has been jacked up so that the number of orders can be reduced. So the EOQ that we're supposed to go for product 1, anytime we place an order, so that we don't exceed 20 orders in a year, based on what the organization wants, is 849.79. Then you can go and calculate also what is the number of orders for product 1 from the same supplier, and that is your demand over EOQ. So you can calculate that. That is giving you 12,000 over EOQ, which is 849.79. This is why you're calculating the number of orders, because you want to check when you sum all the orders now based on your adjusted EOQ. Is it giving you a value which is within 20? Because it's supposed to give you that, because now you're adjusting the EOQ. So, and that if you do that, that will give you 14.122. You can press calculator. Then you go again to product 2. You follow the same principle, like I said. EOQ for 2, square root of 2D2. That means you are dealing with the demand for product 2, K plus L plus lambda over IC2. You substitute based on the parameters given product 2 and your lambda, which you have calculated as 2008.55. You see EOQ for 2 has been adjusted now to 268.71. Then you can calculate the total number of orders using your D over EOQ again. You see you are getting 4.466. So the number of orders now is also adjusted for product 2. Then you go again to, did I skip something? I think yeah, you go again to product 3 in slide 25. You do the same thing to get the adjusted EOQ for product 3. And if you do that, you get 84.97, and number of orders now has been adjusted to 1.42. If you want to know whether your answer is right, just add the adjusted number of orders that you have calculated based on the adjusted EOQ. If you add 14.122 plus 4.466 plus 1.412, you see it will give you something maybe exactly 20 or something close to 20. That means now you have adjusted the EOQ and the answer is right, because that is the desired from the organization. So does that make sense up to this stage? Please confirm before we go to the last aspect, which talks to case 2. Does it make sense, please? You can just use a thumbs up. If you have question, ask. It's not difficult, it's just that you need to familiarize yourself with those parameters. Ndikinda, are you still following, or you watch the recording again?
I'll watch the recording again, sir.
But it's not difficult. It's just you just need to, because the designer from your side at least is making sense. It's just a lot of parameters, but just follow it to the letter, the way I'm saying it. So it's just a lot of information. Hence, when you get maybe tomorrow when you're now fresh, go through the recording again and do what I've said. But let's do the last one quickly. So the next question which you were asked, and that will be the last one, then I won't disturb you again for today. Then I will just give you tutorial questions so that you can do those tutorial questions in line with this. Look at this question, and that is talking to case 2 in terms of the ordering policy that the organization might want, in terms of the money they want to tie to inventory that they are holding. They said if the money value of the average inventory to be held at a particular point in time at home city appliances is $140,000, what is the EOQ and the number of orders for each year for each TV that will satisfy this constraint? So just like what you did with the number of ordering, you also need to go and find what is the average amount of money you are tying to inventory for product 1, for product 2, and for product 3. Then you sum them together and check whether that total sum of the money you are tying to inventory for that 3 inventory, is it more than 140,000? If yes, that is when you now proceed. That is when you proceed to use this formula that I told you, which is talking to case 2. Get the adjusted EOQ using this formula and find your lambda from here. But if no, if the result you get is less than 140,000, that means the result you got from procedure 1, which is the question number 1, is the best EOQ and the number of orders are fine, because the monetary value I shared with them is less than the desired monetary value desired, which is 140,000. But if it's more, you have to use this formula to adjust the EOQ. So let's go and check how we do that. That's why I'm trying to explain the step first, then before I show you the computation. So if I want to find the monetary value for the average inventory that you are holding for the 3 products, this is the formula you use. Let me just zoom it. You use this formula, which is Q1 over 2. Q1 is talking about the EOQ you have computed for based on your first question, because we are finding the average inventory. And remember, average inventory is more like your EOQ over 2 multiplied by the price of the item. So that's how we are getting that, which is Q1 over 2, because we are looking for the average inventory multiplied by the cost of that. And that will give us the monetary value for that average inventory we are holding for each item. So that will give us Q1 over 2 times C1 plus Q2 over 2 times C2 plus Q3 over 2 times C3. Then you put your EOQ for Q1 based on the result you have done first for the first question. And that will give you 489.898 over 2 times what is the price of product 1, 500 plus Q2, which is EOQ for 2. We have calculated it from the first question as 154.92 over 2 multiplied by the product price for product 2, which is 500, then Q3, which is 48.99 based on the result of our first question over 2 times the price of the item is, as given in the table, is 500. Then you can simplify this. You see the price you got. The average monetary value of holding these 3 items is 173,452, which is now more than that 140,000 that the organization wants. And since it's exceeding that, that means you have to find the adjusted EOQ using the formula I showed you. But if the result you get here is less, it means that the EOQ you got for step 1, you just conclude is the EOQ they must order, and the number of orders to be placed per year should be that result you got from first question. But because this value is higher, now you go and use this formula like I told you. Where is that formula now? Let's go and use this formula in case 2 to adjust the EOQ, because I must go and use this formula to adjust the EOQ, because the average monetary value is 173,000 plus is more than that 140,000. So we are going to use this formula. So if we use this formula just to show you, we are almost done. Then I will leave you now. And that is where you see us using that formula. We brought the formula of the case 2 now, and we start by calculating the lambda. I told you K is the average product ordering cost. You go back to the table. For each product ordering cost is 1,000. So it's 1,000 plus 1,000 plus 1,000 divided by 3. So that K is the average product ordering cost, and that gives you 1,000 over 2. I told you B is the monetary value tied to average inventory desired by the organization. And according to the question, they said the B must be 14,000, 140,000, sorry. So you bring in 140,000, then you square it, then you do the same thing for simplifying square root of dk times ck. You know how we do that now. So that's square root of d1 times c1 plus square root of d2 times c2 plus square root of d3 times c3. We have 3 products. Just plug and produce the demand and their cost for each item. Then I is the average what do you call it, opportunity cost, which is the holding cost that you have here, which is 0.2, 0.2, 0.2. You add the 3 together, divided by 3, and that gives you 0.2. So you bring it here. Then this is the one I want you to go and confirm at home, because I know some students used to say they didn't get the same answer. So please just confirm this lambda at home. If it's not the same, just put the right answer after you press the calculator. Then all your lambda here, just change it. Instead of 0.37, any result you get, change it to the result you are getting. But I know few students used to tell me in the past that they didn't get this when they press calculator. Maybe I made a mistake there, but confirm when you get home. But for now, let's just assume that the lambda is 0.37, but I think some students are saying it's not. So just confirm what you get. But if you get any value which is different from this, just change that result of the lambda, and now use that to compute your new EOQ if the lambda is different. So that means it will adjust the EOQ. The answer will be different from this because of the lambda. But let's assume the answer is 0.307. Let's assume it's correct. But you confirm and you let me know on Friday. So then EOQ for 1, now you can now use that formula, which I've shown you in case 2, which is 2D EOQ for K, which is we are dealing with for product 1, which is square root of 2D1, K over I plus lambda over C1. Then you can put your parameters there. That is 2 times the annual demand for C1 is 12,000. The K, which is product ordering cost for product 1, is 1,000 from the table. Then I is for product 1, which is the holding cost in the product 1 is 0.2 plus lambda. Lambda is, I told you for now we are presuming is correct, 0.37. Then multiply by the cost of buying product 1 is 500 from the table. Then you can find the EOQ for 1. But if this lambda is not 0.37, I told you, you can adjust it and recompute your EOQ. Then you do the same, I think I forgot. Then you also, after you calculate the EOQ, you calculate the number of orders based on this adjusted EOQ, which you calculate by annual demand over EOQ. And that will give you 12,000 over the EOQ, adjusted EOQ I've calculated. And that will tell you that the number of orders that need to be placed now is 39 to meet the monetary value of that 140,000 that the organization wants. Then you follow the same procedure for EOQ for 2 in slide 26. You use the formula again, put your demand, your product ordering cost and the price and the lambda and the I for product 2. Then you get this result. Then you compute your new number of orders also, D over EOQ. It's the same procedure, it's just that you have many computation. Then you do for product 3, follow the same principle, calculate your adjusted EOQ, then calculate the new number of orders by finding your D over EOQ, and you get that. And if you have done the right thing, you see that this answer would be correct if you find the average monetary value for the new EOQs you have computed using the formula of, for the new adjusted EOQ you have computed, you can verify your result by using this formula again and put your new EOQ here. You see that the result you get now will be 140,000 because you have adjusted the EOQ based on the formula for case 2. So, but just verify that lambda there for this case number 2 to answer question number 3. But if it's not 0.37, adjust, revise your EOQ computation for EOQ for 1, for EOQ for 2, and recompute the number of others. So I hope that makes sense. And I think with this, we are very good with. Does it make sense with what I've said? At least, did you follow? I'm not saying at least to some extent. I know you still need to listen, go through the recording. Okay, perfect. Good. So please, what I would advise, because we have said many things today, please make sure you go through the recording at a very slow pace. Do it one by one until you are very happy. Then if you still need clarity, you can always send an email to consult. So, and I think with this, let me show you a question you must try. If you go to, let me show you where you get the question on multiple product EOQ model. I want to show you. Where is it now? I just want to take you through that place so that you can know where to get the question on multiple product EOQ model from Moodle. So you go to Moodle if you want to see the tutorial question on multiple product for EOQ. You scroll to your deterministic unit 4, deterministic inventory models, click it. When you click it, you click on under the learning unit outcome for deterministic inventory models, click read more. Then you can see we've got tutorial questions on multiple product EOQ model. You can see that's the PDF document. So you can open that. So you see the tutorial question that I've given there. There are 2 questions there. So try all those questions, follow the same principle to the letter. You'll be able to answer all these questions that I've asked for question 1 and 2. You see, it's a similar structure in terms of the example. Just follow the principle to the letter. Then you'll be able to answer all these questions, which is question 1 and 2. So I hope you can see that. Are we all sharp? Okay, good. So I think with that, thank you very much. Let's call it a day. It's a long day. We had a lot to discuss. So please don't forget on Friday, we are meeting 5 p.m. 5 p.m. I will send the link Friday morning at the latest. Then we'll meet. Then with respect to the assignment, the due date has been extended because we wanted to have extra class till Wednesday. So Wednesday, 12 midnight, so that you don't come up with the excuse of why you are not attending the class. You need to be there. The extra class on Friday. So I think with that being said, let's call it a day. Thank you. Yes, in the kinder, yes. I see your hand is raised.
Yes, sir. So is this where the summative test is going to start from today's session?
Yes, the summative test actually is not starting from here. It's going to be 4 modules out of 5. We are doing 5 modules. Actually, we are doing, what do you call it? Because don't forget, so far we have covered transportation problem. We've covered deterministic and probabilistic dynamic programming, then deterministic inventory models and probabilistic inventory models. Then we have network model. So I think I will confirm with you on Friday. It's supposed to cover 5 out of 6 model because it's 45% according to departmental rule, either 4 or 5. But I will confirm with you on Friday. So I will
Okay,
let
sir.
you know.
Thank you, sir.
But what I would advise for now, I know transportation problem will be there, so start revising those. And also your deterministic dynamic programming. So it can either be 4 or 5 out of those 6 modules that we're supposed to cover. Because after probabilistic dynamic programming, we have network models, but it's only one concept. So that one is just is your short model.
All
So
right.
we are finalizing that on Tuesday. But I will confirm the exact modules you must focus on for the summative test on Friday.
Thank you so much, sir.
You're welcome. So I think with that being said, any other question? Any other question? Are we all sharp? Can use a thumbs up reaction if you are all sharp. Good. So I think with that being said, thank you. Let's call it a day. Please make sure you go through the recording. Make sure you go at a slow pace. Have a nice evening. Bye for now. See you on Friday by 5 p.m.
Bye, sir.
Thank you. Bye-bye. Bye.